Good morning, everyone. Thank you for joining me here on this 8th episode of Professional Media here this morning. Sorry if my voice is a little bit scratched. I still haven't woken up yet. But today we're going to talk about the difference between 8-dimensional audio or 3D audio or spatial audio, whichever term you want to call this technology. And that in comparison with stereo panning. Now, when I use the quotations there, what I'm trying to say is there is a lot of content producers out there that produce what they call spatial or 3D dimensional audio. And it's technically the content that they're producing is just stereo panning. So I want to discuss here the difference between those two things and why stereo panning is not technically spatial or 8-dimensional audio. So I'm going to switch my screen here, but before I do that, I just want to mention that I have about 15 episodes in total that have just come off the top of my head here that I've written down my notes. So I'm just going to give you the brief introduction titles of these upcoming episodes and the different topics we'll be discussing. So today, in this 8th episode, we'll talk about, like I said, the difference between dimensional or spatial 3D audio and stereo panning, which is a misleading term it's not a misleading term, sorry. They use stereo panning and they mislead to call it spatial audio, which is technically stereo panning. So the next episode, episode 9, is going to talk about know your vocal position. If you're in a group performance, rather than just performing solo on stage, if you're like a group artist and you have more than one vocals, what you need to know about your vocal position. So that's the next episode on episode 9. Episode 10 is going to talk about 8th-dimensional audio from mono-stereo signal. So how to produce dimensional audio using a traditional mono-stereo signal or track. This allows you to convert current generational audio, mono-stereo, into next generation 3D spatial dimensional audio. So you can take any previous track and convert it over. So this is going to be a very exciting episode in episode 10. Episode 11 is going to discuss and talk about 8-dimensional audio or dimensional spatial audio from a binaural ambisonic microphone. So this is in contrast with producing audio out of like in episode 10, where we're going to discuss producing audio from a traditional mono-stereo signal. Episode 11 is now going to discuss how to capture natural audio from a binaural ambisonic mic. So you don't really have to go through the process of converting a mono-stereo signal. You'll have a microphone that will capture that 3D signal. So that's what episode 11 is going to discuss about. Looking into episode 12, we'll discuss and talk about the introduction. I'll be introducing to you natural audio. But you know what? I'm not going to get into that right now. So that's I'm not going to start that episode yet. But basically, there's a lot of EQs that are pre-built into a phone and devices that we use. But I was in the shower one day and I was just wondering, why do we have all these preset EQs and why are they structured differently? And do our ears even have an EQ built into them naturally? And if they do, why are we creating synthetic equalizers? Why not discover what our natural EQ is so that way we can implement that or add that natural EQ to software so when we wear headphones or whether we're listening to PA speakers or any kind of projected audio, that is going to sound just like we hear it without wearing headphones or listening to a projected audio. So it's basically replicating true natural audio. So this is a very exciting episode. And that engineering that I've been working on is not completely released yet. It's about 80% completed that I've been studying and working on, and I'm almost there. I'm almost cracked the code of the natural human ear EQs. So that's very exciting, but I'm going to get into that topic a bit later. So looking at episode 13, we're going to discuss why surround sound doesn't work for a large audience. Now that's a very probably a controversial topic of people would think that, okay, well, you're having a large audience. You can't just have your stereo speakers in the room. You need to have like an environment full of speakers because you're in a huge, large concert or a conference or like a crusade. And with a huge audience, you would need surround speakers, right? Naturally, you would think that. Well, after many years of experiencing setting up in a large environment and realizing there's a lot of pros, but there are more cons than there are pros. So I'm going to discuss why surround sound is not recommended and why there are more cons to surround sound applications in a large audience environment, and what I would recommend to set up that would solve a lot of these problems that you would end up facing. So that's going to be episode 13. And then episode 14, moving on, is dedicated audio, why it's important to have a dedicated audio signal for recording, for your audience, and for your performers on stage, rather than having the audio combined and conflicting with each other, why it's good to have that dedicated audio. So I'm going to talk about that in episode 14. Going into episode 15 is the purpose of in-ear monitors, why that technology was invented, and what are the problems that were solved by going to switch to moving forward with in-ear monitoring compared to going with stage monitors. So that's the 15 episodes so far that just came to mind, that I just wrote down the titles, and I will dive into those topics and give an in-depth visual of each of them as I go through them. So getting into this one today, episode 8, we're going to discuss, like I said, the difference between dimensional spatial audio and then stereo panning. So, which is often misled as spatial audio, and it's not. And today you're going to see why. So let me switch over to my screen here. I'm going to go to the desktop. And as you see here, you're looking at Ableton Live Suite 11. And this is just one of my templates that I've been working on with an engineering project. And with this, you see here, this is my Shure Super 55 microphone, duplicated into 4 channels with a group channel, which is grouping these 4 channels and then having the final effects on this group channel. Because as you see here, each of these channels have different effects put on them and equalizers and positions. So I basically created like an orchestra of my microphone just to fill it out so it's not just so basic. Now keep in mind that Zoom is recording this at 192 kbs, so you're not listening to my standard audio recording quality, which is generally at 96 kilohertz, 32-bit rate in WAV format. Now I can record a real audio experience for you in later videos, but for this video it's not relevant in this training video. So it requires me to do additional post-production to combine the audio and video together rather than just doing a live recording with this Zoom meeting. Now, in order to do a live recording like this in higher production quality, I'm going to need to upgrade my MacBook Pro. And currently on the market, there is a Mac Studio, but it's desktop, and it has 20 cores in it for the CPU, which is great for Ableton. But I'd like to see that technology trickle its way down to the laptop style Macs, so that I'm able to continue taking my work out. So no upgrades on the table for now, but who knows, in the future, we might be able to produce some better content for you without all those unnecessary steps of post-production. So what I want to do here is I just want to mute my microphone that I've set up in this template with all my filling out that I did to create this full and rich orchestra of dimensional audio for you. I have my microphone in various positions. So because it would be like me standing around you or duplicated myself 4 times, and I'm standing at the 4 corners of you. So this is one technique that you can use, is instead of having a specific position of the dimensional audio where someone can identify this person is in this direction, you can duplicate yourself and position yourself in an entire direction around the person so that they will still be able to identify a dimension or a space, so to speak, but not the position of that sound, because that sound is coming from all directions. So that's basically what I did here is I filled myself out in all directions to create that full rich environment. Um, and it just makes the sound more spatial. So that, and if I turn this off, you will hear the difference. If I go to just general mono stereo signal, I'm going to give you the natural audio of the microphone that's coming into the signal, and then I'll give you this template. So I'll toggle between the two for you. So let me now mute the microphone quickly for a second, and I'll quickly set up the other one. So this is basically how the microphone naturally sounds when you buy it out of the box and you plug it in with XLR audio cable. And this is what you're going to hear with every other traditional analog digital mixer. So when you're working on a stage and you're in a standard performance, you're going to hear this kind of sound. This is, and people would think, well, oh, this microphone, this, you know, it's kind of cheap. It doesn't sound that good. It's not the microphone. It's basically how software is managing that audio signal. Because what you're listening to right now is raw audio signal, which is like mono stereo signal. But moving into like the next generation, you're seeing the benefit now if you switch from going from stereo, which is left and right. Because like if you notice, if you take off one ear, you can still hear it on the left. And if you take off the right ear, you can still hear it on the right. So this is a stereo signal. But mono signal is basically, you can have a mono signal split into stereo where it's taking a single audio track and then it's splitting it to left and right. Or you can have a dedicated microphone that has left and right microphone capture source. So this is just a stereo-based microphone that is plugged in through standard XLR cable into my USB audio interface, which is the same as like a digital mixer with all the dials. And you're hearing the raw audio. But now let me switch, turn this one off here, and go back to my dimensional audio that there you go. So you can see the difference. It's huge difference. And if I turn off some of these, you'll see like these are the ones that I've created. Let me just put on number 2 for a second. So here's number 2. And if I turn off number 2 and switch to number 3, here's number 3. So you can see this one has a different sound setting, but it's more towards the right side of the ear, right? And if I turn this one off, and now you hear this one is more on the left side of the ear. And it's a little bit different than the one that was on the right. I just noticed that Zoom is converting my 8-dimensional audio to mono signal and then to stereo. That's why it's showing the same volume on the left and the right, and you're not actually hearing what I'm trying to demonstrate to you. So I'm sorry about that, everyone, but stay tuned to the end of this video for the real 8D experience, and I'll add Ableton's raw audio in post-production for you. I could set the one on the left the same as the one on the right, so it had the same strength, the same position, the same closeness to the ear. But I made the one on the left a little bit further away, so the one on the right is more emphasized than the one on the left. So it's coming more towards here, but the purpose of it being further away on here means that this is going to be more of like a backup of my vocal. So I'm taking my voice and I'm creating a backup channel of my voice. And the third channel is the primary channel of my voice. So that's what I did here. And if you look at number 5, this is where you're going to get, it sounds, the chorus right here. You're hearing the chorus. You're hearing how it's creating like a very rich, heavy, clean digital effect of the voice. But this is very subtle. You're not going to hear that when you have all the other ones turned on. So let me now go turn on number 2. And this is what you're hearing now. It's adding more in. Let me turn on number 4. And it's adding even more in. And now let me turn on number 3. And now this is where you're getting the final finished product. And then if I go to the groups takes all of those 4 channels. And then I add in probably some gain here on the channel EQs. And then I add in Vocal Rider, which is now, if I look at it here, Vocal Rider, as you see, it's moving real time. So the Vocal Rider is basically controlling the decibel of my voice. So sometimes when I'm loud, it'll drop it. Like if I say, hey, you see, look at that. I shouted, but it dropped the voice. So that way the volume was consistent. So the decibel is never going to be too high or too low. So if I'm speaking loudly, it's going to drop it. And if I'm speaking quietly, you see it's above the 0 mark. So it keeps the volume consistent whether you're quiet or loud. Now, on a traditional, even a digital expensive like Behringer X32 mixer, which it's a huge, massive mixer, and it looks like if you have one of these in the room, it looks like you're, top-notch producer. But even with those analog digital mixers, they don't have these vocal rider capabilities. So even with one of the expensive thousands of dollars mixer in a stage environment, and instead of using Ableton going fully digital, you're going to have the problem of, and you talk to any sound engineer, they're going to tell you, people who are singing on the mic, and sometimes they're singing further away from it, and see, I just stepped away from it and the volume was still normal. I go closer to it and the volume is still normal. This is the thing that would happen on a stage is the vocalists, they would step away and go forward, and sometimes they would be quiet and sometimes they would be super loud. And as they change their vocals, in order to keep it consistent on like a digital analog mixer or even just an analog mixer, you're going to be like this, turning the dial up, turning the dial down, turning it up, turning it down manually. And you're constantly doing that to keep the volume consistent, so that way when they're quiet, they can still be heard. And when they're loud, it's not going to create this clipping distortion. So imagine doing that if there's a group of vocals. You don't even have 7 hands to be turning the dials for each of these vocalists. And imagine if you did, it would just be, it'd be pretty funny to look at, seeing the sound engineer going crazy on all the dials, keep turning them up and down, turning, to keep all the vocals consistent. So it wasn't really even possible unless you had like a whole team of sound engineers, like 15 sound engineers working alongside each other on the stage. Some people are controlling through the iPad, some are controlling through the console, and you'd have everyone working together, a whole like army of sound engineers working to keep the vocals in check. But now you have software, auto intelligence, to be able to be a whole production team for you. So that actually wasn't part of the plan of this topic, because I'm extending it a little bit further than I wanted to, but I just wanted to touch on something that was very important on one of the main highlights of going digital compared to sticking with analog or or I call it hybrid digital, which is analog digital, which is like the Behringer X32 mixer or the Midas or any one of those major hardware mixers that are out there that have digital capabilities, but they're basically analog. Compared to going fully digital with like a USB interface and then using Ableton to control everything of your raw audio signal coming in. So this is where I specialize in as like an 8-dimensional sound engineer and live stage recording specialist. So with that being said, let me just close this vocal rider here. You're probably having fun looking at it. And I want to show you stereo panning. I'm just going to demonstrate to you stereo panning and what that looks like coming in here. So let me just delete this audio track here because I don't even need it anymore. Delete, there we go. So what I'm going to show you now is I'm going to go to add in my Waves NX, which is basically, if you look on my headphones here, I'm just going to switch here so you can see my camera. Stop share, there we go. Okay, so now you're seeing my screen. I want to show you on the top of my headphones. You might be wondering what the funny little device is up here. Now this is because I was working, like I told you, with dimensional audio long before it became publicly recognized or even launched in softwares and hardware by major tech companies. I've been kind of experimenting with it and testing this technology once I discovered it, but way back previous 2020, when I was working with surround sound and seeing through surround sound that you can position sound in different spots of the room. So I ended up looking into Waves. Waves is one of the best for Ableton, actually, because basically Ableton is not just a software, it's almost like an operating system. So like your phone, you get a phone, whether it be iOS or Android, like an iPhone, and there's an app store, and the app store has unlimited apps from developers that are producing apps all the time. So Ableton is like that operating system, and there are developers around the world who are producing plugins, audio management features with different effects that you can customize your audio limitlessly. So Waves is just one of those developers and product producers that I just love using because their plugins are just phenomenal. So I wanted to show you that this little device here is one of the hardware that Waves made way back before you see now in this modern generation of 3D audio coming into the market, where they have headphones that have built-in head tracking to be able to simulate stereo panning or positional audio. So with that being said, I kind of got like the what do you call it, like the early stages of what head tracking was, and you could just add this device to your any kind of headphone, and it now takes your traditional headphones, and these are the headphones like I recommend. Let me show you. It is the Audio-Technica ATH A990Z. These are one of the best I can recommend for the price for studio production. And I'm not trying to sell you anything because there's no incentive for me to recommend these things to you other than I just want to give you what I think is best. So from my experience. Now, this head tracking from Waves can go on any traditional headphone. And this was the early stages before headphones were released, like I said, with head tracking capabilities or Bluetooth head tracking movement. So it sends a left signal and a right signal, and it tracks it in the computer or device, mobile device, based on where you turn your head. And I'm going to demonstrate that to you on how it works. But for me, I'd have to turn it on. And that's what this little funny thing is on my head. And I don't rarely use it because stereo panning or positional audio is kind of neat. It's nice, but I would like to not have to, how do I say it? When you're listening to something, you're not going to be like, here, I'll give you an example. You're not going to sit here and listen to something and be like, wow, that sound is, oh, I see, it's right there. It's staying there. Wow, it's amazing. It's not moving. We don't do that when we listen to things. So normally when we're listening to something, we're just kind of keeping our head in one position. But when we're doing that, we would love to be able to identify or be able to hear that volumized space of sound without having to move our head around to identify it. So this is why I see it kind of like, okay, it's a nice, cool product. And I guess when you're, well, there's some benefits to it. For example, if you're working in an environment and you're doing sound production, for example, and you don't have a surround theater audio system in the room, like a studio setup, and you need a quiet environment, well, now you can put on your headphones and have a virtual studio to be able to hear sound from surround sound in multiple directions. So basically you put on the headphones and you'll hear the audio coming from specific designated sources. Sorry, my goodness. You'll hear the audio coming from specific designated sources with just wearing the headphones. So you can have a virtual surround sound speaker system through your headphones while you're working in post-production in studio. Okay, there's a benefit for that, right? But when it comes to just the average person out there, that's why I see it. It's a very small market of people that would really need it. So for me, I don't want to really have that, because what I would want to focus on, instead of having like projected surround sound through my head for doing studio production, I want to get out of surround sound, because surround sound is old generation. Why would I want headphones reproducing surround sound into my head when I can just skip that and go to fully 3D spatial dimensional audio? So it's almost like you can, basically what it is you can take surround sound and you can take surround sound speakers and you can place that surround sound inside of your headphones. That's basically what it does. And then you'll identify the position of those speakers virtually, like invisible speakers, as you want to say, because you can have it positioned left and right. And I'm going to show that to you. So what am I trying to do? Explain it to you when I can just show it. I'm going to do that now, so let me go back to my camera. And I'm just going to add it here. You're going to see the sound is going to change a little bit because it's just going to load a default, and it's not going to be optimized. So pardon me for that. Okay. So as you see, the sound has changed a little bit, which I can fine tune it later because it just loaded a default stereo panning. So as you see here, you see my face. There's two ways you can do it with this Waves NX tracker. And headphones have this built in, so you're not going to see this if you buy like spatial capable headphones or dimensional 3D headphones, because it has it built in. And this is basically a visual of what it's doing behind the scenes with your mobile phone. Your mobile phone is capturing all this data, which you're seeing on my screen. And you don't normally see this when you're using built-in 3D headphones. But this is, like I said, the early stages of it, so it had all that visual in there. So this is one way. You can do it with camera tracking. And as I turn my head, you can see the box is changing because it's tracking my face. And also the audio is changing. So it sounds like, because I have two speakers, if you look at the speaker setup, so as you see here, this is my head moving because it was tracking, right? You were seeing that tracking. And this is what's happening. With my head moving, it's capturing with the face tracking with my camera on my computer here. So you see the speakers here. Now I can stretch out these speakers and it changes the sound. You hear the sound is changing because the speakers are spreading out. So it's like it's virtually creating speakers in the room. And as I turn my head, the sound is changing slightly based on those speakers virtually being positioned in my room. So this is what I was saying, how it can replace having physical speakers in the room, where now you can have this head tracker create virtual speakers for your room environment and be able to identify, as I'm turning my head, where those speakers are in the room. Like it would sound like if you had those two speakers in the room physically. So that's what that is there. And if I move these a bit closer and I bring it towards the center now, these speakers, as you see, are really close together now. So with that, you're going to notice as I turn my head, the sound is coming from the center of me. Because see, it looks like the speakers are right in front of me now. So if I turn my head, since the sound source is coming from right in front of me, you're going to see it's going to move more recognizable. So if I turn this way, the sound has changed dramatically. And if I turn this way, it changes also dramatically. So the sound is kind of positioned in the center of me. And if I turn left or right, the sound stays in the center as my head turns. So this is what's happening as you're looking at the screen here and you're hearing the sound is changing. It's corresponding with my head movement. So this is using the face tracker to do that. And let me get back out of this to go to the camera.
Thank you for watching. I just want to give an important notice here. What you're listening to is distorted audio due to Zoom's compression. So you're not actually able to hear the audio that I'm trying to visually demonstrate to you here. So just discard the audio, focus on what I'm trying to show you on my screen so that you're able to see how it all works, and stay tuned to the end of this video where I'll record right raw out of Ableton so you're able to hear what I've been visually showing you here on my screen.
So now if I do the Bluetooth, as you see, these numbers are changing real time. If I go to the Bluetooth, and let me turn this one on now, I can take off my headphones. You see the light is turning on. Now it's turned on. You can see that says Waves on my screen here, that it's able to track and pick it up. So now I can do this, and I can do it the same now, see, with the head tracker on the Bluetooth, which is great. So you see these numbers are changing real time. So this is the difference between dimensional spatial audio, 3D audio, and stereo panning. And stereo panning is just what I demonstrated to you right here. And this is what it's doing in stereo panning, is it's tracking the position of my head to create a positional sound of that audio. Like I said, the speakers I got the left and right speaker here. But if I bring them to the center to kind of simulate like a mono signal there, then as I turn my head, you're going to see the sound is moving left to right, basically as my head is corresponding with that sound. So the numbers are changing real time because it's tracking the movement of my head through the Bluetooth tracker or face tracking technology. And that's how it's creating positional audio, which is stereo panning. It's panning left to right as I'm moving my head. But that is completely different than spatial audio. Just because, let me turn this off now. Okay, thank you. So just because this device is tracking the position of the sound, so as you were seeing, it takes the sound and it puts it in a certain position virtually, so that as it stays in that position and you move your head and the sound is not moving from that position, but your head is moving from it to hear it how it would sound in that position. Like if I'm turning to the right, I'm going to hear it more on my left ear where I'm pointing. You see on my camera. So let me switch here and go back so you can see this. Stop share. So if the sound is here and I turn to the right, the sound technically is going to come more on this ear. And if I turn to the left, the sound is going to come more on this ear. So they use stereo panning to increase and decrease the volume according to the tracking movement of your head to simulate that position of that audio sound. So that's why I say, like, people might mistake that as spatial 3D dimensional audio, because now you're having positions of that audio in a certain dimension of space. But it's not technically 3D audio or dimensional audio unless you can identify that there is space to that audio or there is a dimension to that audio. So in order to have 3D audio, you need to be able to identify whether that audio source is 5 feet away from you or 10 feet away from you, whether it's up high or down low, or whether it's behind you or down beneath behind you, or above your head or right in front of you, or close to your right ear, or further away from your left ear. So you need to identify not just the position of that sound, but the environment of that sound for it to be dimensional audio. Because that's why it's called spatial or dimensional, because there is a space to it, there's a dimension to it. So that's that big misconception, and it's misleading for people to be doing stereo panning of sound where that stereo panning is missing the major attribute of having a dimension or space to that sound. So now let me show you another template that I created, which is going to now demonstrate the difference when we're looking at dimensional sound. So I demonstrated to you right now about the stereo panning, but now I want to demonstrate to you spatial. Thank you for joining me back here, everyone. This is the moment you've all been waiting for. This is the raw audio coming out of Ableton without any kind of compression or conversion happening from Zoom. I'm sorry about that, but this is requiring me to do some post-production here for you to take the recording of the audio separate and combine it to the video. I would love to be able to add this real time and do like a live stream, but I need to upgrade my MacBook Pro to be able to handle all that CPU power. So this is audio coming right out of Ableton at 96 kilohertz, and it's recorded at 32-bit rate and wave format. So I'm going to go through the steps here as you remember what I said. So what I'm going to do now is I'm going to mute all of them, and then I'm going to unmute one at a time so you can actually audibly hear the difference and the reason I duplicated my mic input channel 4 times and then grouped it together with the 5th channel. So I'm going to go through it and show you why I did it this way and one of the benefits of creating an orchestra of a single input. And I'm unmuting the second duplicate of my microphone channel. And this one is to give more of a sound in the back and the rear. You'll notice that the sound is coming more from behind your head if you're wearing headphones. So this is to create more of like an environment. And the purpose of this channel, this duplicate of my mic channel, is to create an environment of my microphone. So if I go to channel number 3, and let me mute number 2 and switch it to number 3, the third duplicate. And this is the third duplicate of my microphone. And you're noticing that it's more, the sound is coming more towards the right side or your right ear. So this is what I did with the sound, and it's more emphasized on this ear. And if you notice, if I switch to the fourth duplicate of my microphone channel, this is more towards the left ear, and it's a bit further away, and it doesn't have that strong emphasis in the voice. So I wanted it a little bit more subtle than the third channel, because I want the third to stand out more than the fourth and the second. It's more of the backup of my voice behind my head. And the third is the primary vocal that I want to stand out. And the fourth is, as you're hearing now, on the left ear to give a more of a spatial environment to my voice. So let me switch to the fifth now. And this is the fifth. It might sound very strange, but you won't really recognize this when all of them are unmuted and turned on. So the fifth just basically fills out my vocals, and it's using a chorus effect. So it kind of like creates a more strong, rich, heavy sound, which fills out your vocals for people who have like deep voice. So what I'm doing here is I'm adding this chorus on channel 5. And if I unmute number 2 for the rear, like the backup vocal, and you can see number 2 is unmuted and is combining with the chorus right now. And now if I unmute number 4, which is the left side of my ear, to kind of fill out that spatial effect of my voice. And as you see here, now it's filling out a little bit more on the left ear. Now when I add now the third one, which is my primary vocal, you'll see how it all blends together beautifully. So now this is the third one, and see what happened. It just created an environment, a dimensional sound of my one microphone input channel.
So now you're hearing my mic with just the raw audio coming in from the XLR cable, and this is just raw signal coming into my Shure Super 55 mic. And as you can tell, like you might think, oh, this microphone is not that great quality, but this is just raw audio signal that you're hearing, and you would hear generally like this on any kind of analog or hybrid semi-analog digital mixer like the Behringer X32. This is what it would sound like unless you add some equalizers on there and some maybe a few effects that you might get pre-built into a digital hybrid analog mixer. But you can see the difference going from like stereo signal, and that's what you're listening to right now.
And now right away you can hear the difference of how much more environmental it sounds, and rich and full and clean. So, and the vocal rider is controlling, like if I'm stepping away from my microphone, see, it sounds the same. And if I'm going closer to my mic, it still sounds the same. And if I'm shouting like, hey, you see how the microphone just dropped in decibel, so it can keep your microphone from clipping. And this is the amazing thing about Vocal Rider and Ableton being able to create an orchestra of a single channel by duplicating your channels and then creating different positions of those channels to create like a surround environment of a single channel. And this is what separates stereo panning from dimensional audio. This is going to be very exciting. Please hold on. So now I'm demonstrating the head tracking to you like a Waves NX, and this is, like I said, a pre-template, so it's not optimized, but this is basically what you're going to hear when you have a head tracking device, whether it's an additional one that you add to like traditional headphones, or you have like a headphone that has pre-built spatial audio into it, or dimensional audio with head tracking. So this is what happens, and as you've seen on the screen in the previous minutes of this video, if I move my left and right speakers and extend them out, you're going to hear the sound is changing. And this is what I was trying to demonstrate, but you couldn't hear it properly in the audio. But now this is why I'm recording it separate, so you can hear what I'm hearing in Ableton. So if I turn to the right, you're going to hear the sound adjusting. And then if I turn to the left, you're going to hear the sound adjusting also. And I keep going, I turn to the right again, and the sound is changing again. So if I move these two speakers that I've spread out to the center of me to simulate kind of like a mono signal, and now it's just a single speaker in front of me virtually. If I turn to the right, you're going to see that that sound is coming more, oh sorry, if I turn to the left, sorry, if I turn to the left, the sound is coming more on my right ear. And if I turn over to the right side, then the sound is coming more towards my left ear. So that means the sound is staying positioned, stationary. And as I'm turning my head, the sound is moving. And it stays in that one spot, but yet my head is not staying in the same spot.
So this is positional audio, and it can kind of easily be mistaken as spatial audio or dimensional audio, but it's not. All it really is stationary positioned audio. But like I said, unless you can identify an environment of that positioned audio and know that there's a dimension or a depth of field or an elevation to that audio, then you can't really call it dimensional or spatial audio. It's just positional stereo panning. So thank you for listening. I'm going to close this head tracker to get rid of this. But as you can see, there is a benefit to having this. Like if you don't have the flexibility of having physical speakers in your room or your studio, you can have virtual speakers positioned. And just as you see, I keep turning my head. That's why the sound is changing. You can have virtual speakers positioned and stationed in specific spots in that virtual environment and be able to hear it like you would speakers in your room. So thank you for listening. Now I'm going to get into the exciting part of show you what dimensional audio. Let me close this first for a minute. There we go. Go back to my dimensional sound here. So let me now open up a regular mono stereo audio track, an album track, and now start showing you moving that around in the dimension of sound. So that was a demonstration of dimensional audio to you in one of my templates that I've established to take any traditional track and move it around and get a dimensional sound for you. So the difference, what I was showing you, is taking
an audio track and then showing you what it sounds like in mono, and then releasing that mono and putting it into stereo, and then from stereo putting it into a dimension. So where you're able to move that sound around and identify that environment. And that can all be recorded real time. Like you can move tracks around, and imagine what this can be done if you have like a whole group setting of singers and artists to create a positional environment of sound, and then have an ambisonic binaural microphone pre-record that environment. So you add that as like the foundation where you're now taking that mono stereo signal and building off of that to create a full rich environment of spatial dimensional audio for your music album track. So this is, thank you for joining me. It's been quite long, but this episode was very in-depth, and look forward to talking and getting back to StopShare. I look forward to seeing you again on future episodes. Don't miss out on episode 9, where we're going to talk about know your vocal position for group performances. Thank you.